Okay, this video is going to demonstrate connecting to the Raspberry Pi Zero computer in the laboratory, which is connected to a mass flow meter, and this will be the device that you use to perform that component of Laboratory 3 and future labs. In the video, I will demonstrate how to connect to the flow monitoring or the flow meter of the Raspberry Pi, how to start the VNC server on that Raspberry Pi computer, how to connect to the VNC using your laptop or the laboratory laptop. Either is good. Locating the recorder on the desktop of the Raspberry Pi computer, actually recording flow, and then when that's completed, how to cut, paste, and download the data that you've just captured, and as an option also how you can attempt to process the data directly on the laboratory data logger. For what it's worth, that's a slow process because it's a very low powered computer in the sense of what you're all accustomed to. It's probably more powerful than the computer that was used to land on the moon, but not much. So that optional part will be at the end. The actual demonstration that I'm using to make this video is not in the lab, but I have the lab let's call it a data logger, because even though it's physically a computer, data logger will be easier for me to remember. So I have the data logger. I'll go ahead and connect to it and activate it. And remember, this is a video, so you should be able to pause it and carefully write down the steps for your own use. The data logger generates its own local area network, and so each of the lab groups, one of you should connect to it, but don't do multiple connections because it won't be able to keep up with that. And to connect to it, you have to disconnect from the public internet to do so, and I'll demonstrate that. Okay, I'm talking more rather than getting to the point. That's in part to give you a chance as you're developing your protocol to write things down that you can put into your lab report. If you've never done this before, the first time you do it, it's going to be slow and frustrating. But as you get more and more comfortable, it'll should start to make more sense. Okay, a couple of things you'll have to note, either in writing or we'll get it written up on the board in the laboratory. So the name of the network that it's going to generate, the SSID if you will, is CE fluids with a capital F in the word fluids. And then the pass key to that network is the three words one Nico cat, all squished together, and the one has a capital O, the Nico has a capital N, the cat has a capital K. The subnet that it's going to generate will be 192.168.32, and then it's 0.124, so it'll be a 24-bit subnet. I think it's Class C subnet. Anyway, the first three octets are what are important, because sometimes, because to get everything started, you have to actually directly connect to the wireless access point and turn on the virtual network computing. So you need to have that that path. I'll go ahead and just get started. I'll try to go slow. I don't know how much memory I have on this disk to do the recording. I hope it gets to the end. And if it sounds like I'm talking in a bucket, that's because I'm using open source, free download recording software, and it does, my opinion, a pretty bad job with the audio. So if the audio is low, you can try turning it up. I can't turn it up anymore because I get internal feedback and it clobbers everything. If turning it up in speakers doesn't work, try it on headphones. All right. So let's see. My notes to myself are show how to connect to the Raspberry Pi. Okay, so on the screen, you should see a window that has mass flow meter and data logger scripts. Let me do something fairly important here. Let's see if I can get that as a PDF, because I have to disconnect from the public network to connect to the data logger. Perfect, that'll work, and hopefully it goes to my desktop. The reason I want that is it gives me a reference thing. Desktop, choose Save. Okay, and where that will come in important is as soon as I disconnect, all this stuff up here isn't going to work or is just going to go away. Okay, let me find, there is the PDF as my background reference, and ultimately after the connection the script will run is right here. That's pretty much why I wanted this. And in these lab notes it has the steps to access, I called it data logger in the lab notes, so we'll refer to it that. So first it says connect to the Raspberry Pi's Wi-Fi. So right now it's about 20 feet from me, and what I'm going to do when I turn on the recording program is I'm literally going to get up and I'll just blow into the flow sensor, and that'll get the turbine to spin, and we'll get non-zero results. Okay, so locate the SSID. So the SSID is CE fluids. On your laptop computer, if you're using a Windows Meyer, you would go to your list of potential networks, and it's showing up here. So first I have to disconnect from the public Wi-Fi. Done. Then I have to choose CE fluids, and this note right here where it says no internet is correct. This is a completely private wireless network. It doesn't route to anything other than itself. There is no wired connection to the public internet, so all we're doing is connecting to a piece of hardware. Okay, and that's the second comment here. Then it says use a secure shell client to connect to the Raspberry Pi's IP address. So on Windows 11, secure shell I'm pretty sure is built in. So here we would type SSH, and then we would have to give the username and then the Internet Protocol address, a dotted quad address if you will. The username for the device is Pi. Yes, I'm not terribly creative. I'm just using the defaults. And the dotted quad, or the network it's generating, let me take a step backwards. Let's be sure it's actually there. So we want to ping 192.168.32, and it should be number 1. Okay, we're getting good response times, and this is 0% loss, so the device exists, and this computer that I'm recording on can see it. It can interact with it. So now we'll attempt to connect. So the connection is SSH, which means secure shell. So this is going to try to create a shell to the computer. Need to give it the user ID, username, and then the address. Okay, so 192.168.32.1 is the internet address of the class data logger, and it should ask us for a password, and the password to the data logger is fluid lab, all lowercase, all one word. So FLUIDLAB. takes a few seconds. And okay, so the actual host name of the device is PI-LAB-1. As we increase these for different laboratories, this won't affect the first batch of students to do this. But over time, we're going to have multiple devices, and just simply change the designation number, so don't have to move computers around or move data loggers around. So anyway, it's just telling you that this is running a Linux distribution, and the most current upgrade was April 2023, so it's 2 years old, but that's not unusual. It was upgraded in January to whatever the most recent it could be. Okay, so now we have the secure shell connection. The next thing you have to do, and you only have to do this once each time you go to the lab, is we have to create a virtual network computing server. So the command is VNC SERVER hyphen VIRTUAL, and then we're going to explicitly designate the desktop as :1, and three things will happen when I press return. It'll go ahead and launch it, or it will tell me that there's already a server running on :1, what do you want me to do? Or it'll just give a bunch of error messages, which of course you'll never see because I'll delete that video and just make another one. Alright, this is desirable information. It says, okay, there's a new desktop called Pi Lab 1:1, and it's hosting at 192.168.32.1:1, so this is called a port. And now I suggest you set this window aside. Don't close the terminal window until you're done with the lab and the data collection. You don't need to do much here, but I think it's just good to leave it open. It shouldn't matter, but you have to reconnect to shut everything down at the end of your lab meeting. Okay, so we've connected to the Raspberry Pi data logger. We've started the VNC server. Now we need to actually connect to it using software called VNC Viewer. And if you don't have it, you can download it from Real VNC for free. This is complex but safe client software. I already have it downloaded, and we are going to actually, let me do it. I have it already pre-configured, but I will delete the configuration, and this would be how you would do your first connection. So you would type in the address of the server, 192.168.32.1, and then we want to connect through 5901. So the 5900 is the default prefix port for virtual network computing, and you add the desktop number to it, and that becomes your port number. So 5901 is desktop 1. 5902 would be desktop 2 if we launched one, which we didn't, and you shouldn't do it because the laboratory data logger is really not a very powerful computer, and the fact that it's actually serving a desktop, especially when you see the size of the thing, is pretty amazing. So I'll go ahead and attempt to make the connection, and so now it challenges us with a username password. So the username is Pi, and password is the same one, FluidLab, FLUIDLAB. If you don't trust your typing, you can use the look at it. You could choose to remember the password. You probably don't really need to. And then here on this terminal window, you see it says VNC server catchphrase. So it's giving you a public key. So Ruby Design Arctic Pretty Motel Absorb. And This one is using the same catchphrase, so it's attempting to connect to the desktop that we're expecting it to. Press the okie dokie button and wait. And then we have to authenticate one more time because that's what it's programmed to do. So it's Fluid Lab, F-L-U-I-D-L-A-B. This one I don't think lets you see the password, so we choose the okie dokie. Okay, so now we've created the miracle of miracles. You are connected to the data logger. Hopefully I can full screen this. Let's see what happens. Oh, that's better. You notice there's a vertical slider. The data logger's desktop that it's generating is very specific in geometry, and currently it's not programmed to let you adjust that. It doesn't really have the graphics capabilities. Then locate the recorder. So the FlowMeter recorder, there's currently an app on the desktop, so if you double click on that, that will start the recorder, and then I'll show you, well actually it doesn't matter, we'll just do it this way. Remember not to close the window that it creates until you're done. Okay, so if you turn it on, we can either execute in the terminal, open or cancel. Open isn't going to do much for you other than show you what the desktop, what that icon does. We'll open it this time. I think it should just list the desktop. Yeah, it doesn't do squat. So either execute or execute in terminal. I think they both do the same thing. There we go. There's the contents of the desktop. Ooh, this is giving us the registry editor. So the name of the desktop's FlowMeter record, it launches the record script, and this is the actual program that it's going to launch. And terminal equals false means the terminal will stay open. We kill that. Okay, so now we'll go ahead and execute it. And what should happen sometime in our lifetime is a console window should show up. Now, see, I'm not sure I can resize this one very much, but I'm making it big for the purposes of the video. In the lab, you guys have young eyes. If you can read it at the size it renders at, just go with it. Okay, so the comment line 1 and 2 are notes to yourself, so obviously you don't start the recorder until you have all the plumbing up and running and there's water flowing through the system. It's not going to break anything if you start the recorder first, but it's kind of a waste of resources. And then line 2 can be whatever you want. I'm going to just accept the default. Okay, so the dwell time is how long you want each reading to be. So the default is set at 1 second. If you go less than a second, it reports output in hours, minutes, seconds, and 10,000ths of a microsecond. If you take the default, it's supposed to make a reading every second, so normally that's probably going to be the most useful. Or you can make it read over 5, 6, 7 second intervals, and that has some utility if you're doing this remotely and you have to store a day's worth of readings, because 86,400 readings a day is going to be a big file pretty quick. So we'll accept the default, so all you do is enter return, and so now it's set that time at 1. And then the intervals is how many of those 1 seconds you want to read. Now, normally you'll pick some value, but don't go overboard, because at the end of the thing you actually have to be able to copy and paste from this console window into your either file you're going to download or if you're going to process it on the data logger directly there. So I'm going to just put 25. That should be enough time for me to get up and get a non-zero reading. Now the meter constant, that's a part of your lab. You're not told what it is. If you put a meter constant of 1, which is the default, it will compute the flow rate and the rotation counts. You'll get the same number out of it. So a meter constant of 1 means each rotation is treated as a flow rate. Generally 1 is wrong, although that is a way to check the hardware. And part of your task in the lab is determine what the meter constant should be. So I'm going to just put a 1. You need to understand that it's going to report a flow that doesn't make sense with a meter constant of 1. They're normally going to be smaller than 1. And this new system time, just go ahead and press enter to skip. If it turns out that the time is drifted too far, because remember this data logger has no access to the internet, and it has no onboard real-time clock. So every time you turn it off and on, the time gets buggered up. Just going to leave that as is for the time being. And so it's, okay, I think I set this up for how long? 25 seconds. So let me go ahead and get the meter to go non-zero. Okay, so it did a normal loop exit, which means that it made all the readings. It made 25 readings at 1 second intervals. And if we look at the timestamps, there should be either 24, 25, or 26 increments of time. And one of the things you'll have to do as part of your quality assurance, quality control on the data is there's a little bit of luck involved because it has to start the reading in a particular portion of a second so that these will increment by 1. It looks like it worked fine here. And so for the sake of argument, let's suppose that the meter constant is indeed 1. It's saying at 1:55:03 seconds it was measuring 136 liters. At 1:55:04 seconds, 130, and so on. So you can use those time intervals and knowing that the meter constant returns a volume to compute a flow rate. In this case, it also does a summation of the two columns automatically. So there were 800 total events recorded, and so the total volume, because the meter constant is 1, is 800. And I do not know why it issued a segmentation fault. So that is a normal run right there. And then you probably want to, actually let's just get everything. So there is what you're going to want to put into a file somehow and get it back to your computer. Copy that, and probably the easiest file, hopefully there is a text file here in there we go. Okay, so here is our text editor. Okay, that's the file that we're going to want to get back to our computer. So obviously those those first two lines are of some importance. Sampling interval is every second. There are 25 samples, and it's got the recorded values. And did not report out the meter constant. That would be something to put in your report that for future editions that would be really handy. But you can kind of figure out what the meter constant would be by the difference in these two columns. So anyway, we want to save that file. And I think I want to put it on the desktop, so let the save window come up. Desktop. You should name it something other than junk, but this is so I can actually find it. File is saved. I'm going to shrinkify this briefly. There's the junk file on on the desktop. So let's suppose we're done. That was one of our readings, and then to end the program, just click there. You can verify that junk is non-empty. Sure enough. So even though we could actually process this on the data logger, you can notice by the time lag that it's probably better just to get it off the computer and onto our computer. So to do that's a little tricky. So let me slowly work my way through that. You want to go to this transfer file icon. Okay, to send files to the server, to fetch files, navigate to the VNC server icon in the notification tray or status bar, and select file transfer. Okay, that's the wrong one. I always bugger this up. You want to go to this picture right there, right click on it, choose file transfer, and now we're going to send the file back to the laptop. So you choose send files, and then you find the file. So we're in desktop, and we want to send ourselves junk.txt. Choose the okie dokie button, and we can open the containing folder. Now this is back on the laptop computer, and now we find our file. EF junk should be down here. And sure enough, that's our junk.txt file. This is now on a laptop computer, and then you can put this into Excel and do the various processing you need to do. Okay, that's the gist of what you do. Now comes the optional added bonus feature, and then I'll show you how to disconnect. If we want to process it directly on the data logger, assuming you have the time to wait, go into the Applications Office, choose LibreOffice Calculator, and wait, and it's now going to attempt to produce a spreadsheet. Again, there's going to be a lot of lag time because it's a 512 megabyte memory and I think it's 2 gigahertz processor, and it's a single processor. And you're all used to incredible speed because your laptop computers have 4, 8, 12, 16, 32, 64 cores, and they can do multi-threading. And our portable data logger really can't do that, so it has to put everything through one at a time, and things get clogged up. I think it can handle 4 threads simultaneously, but it does not have a symmetric multiprocessing task manager on it. Not Windows. It also costs $12, so you get what you pay for at some point. It takes a while to load. I'm taking this time because there is one feature. I think we can actually open the file directly. Choose open. If not, we'll open it and then do cut and paste. Okay, so we have tab, and it suggests how it's going to parse it, and actually that's not bad right there, so we'll go ahead and accept it. Alright, there is your data. Now the thing that you all have to do is you're going to have to figure out how to parse these time columns. There's several ways to do it. At some point you can isolate the timestamp portion only, the 135446, and then you can use a very sneaky bit of time arithmetic to get the differences in time. These are all 1 second apart. You could probably do it by hand, and then from that you can use that information to calculate volumes per second, or a flow rate, if you will. I'll leave that to you all. Same thing you have to do in Excel. I believe the parsing would be the same way. A slightly more convenient way would be to just, in the original file, just cut and paste the data part only, forget the prefix and the postfix information, and then when it does the parsing, it will probably split out this timestamp into the different components and make the time arithmetic a little easier. So we could conceivably process it here. I guess we could even do plotting here, but I don't think I'm going to. Yeah, what the heck? Let's see what happens. What's the worst that can happen? I waste YouTube time. Let's suppose we want to plot that, so we've highlighted it. We choose Insert, Chart. And similar to Excel, it should have us define the left and right axis. Now our little computer is really struggling. So in this case you could probably get away with a line chart because we have uniform time intervals, but I'm just going to go with that. Okay, data series in columns. Looks like the Y values are correct. Let's see what happens. more or less did it, and then if we used proper graph making, we would label this axis as counts per sample interval, and these would essentially be seconds. It actually did the temporal spacing nicely for us, events in this case. So that will come in handy when you do your report. During the semester, we're going to use this device on multiple instances, so each team should try to get good at it, because this is represents an advancement from buckets and stopwatches. Alright, that's all for this video. Now, the way you would disconnect, go ahead and kill LibreOffice. So in the lab, don't just walk away from the thing leaving stuff running. You have to go through a disconnect sequence. So it doesn't look like there's anything running on the Raspberry Pi anymore. So up here at the top, there's this real teeny menu here, and if I can get it to, we want to choose the X which says end the session. It's going to prompt us, are you sure? Choose yes, and we've now disconnected, although the data logger is still trying to throw a desktop somewhere, and this is where we'll turn off the VNC server. So the command is VNC server -virtual -kill, and then give it the desktop you want it to kill, and it's done. And now we can disconnect on the secure shell window. We do that with the word exit. We are back on our laptop computer. And we can even get back in my house. This happens to be disconnect from the data logger, and now we should be back on the mighty internet, and sure enough we are. Okay, that concludes this particular video. The passwords and IP numbers won't change during the semester unless somebody breaks stuff and I have to rebuild from source. So try not to break the computers. And this is